Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Sebastian Hassinger, host of the New Quantum Era podcast and author of a new book by the same name. Sebastian and I have many things in common beyond our jobs in quantum. We are both podcasters, neither of us has a PhD, and we are both authors of new books, Sebastian's The New Quantum Era and my Quantum Bits, the comic book guide to quantum computing. In a conversation that is more symmetric than the typical episode, we compare notes about the motivation and writing process, explaining quantum computing for non-physicists, debate Sebastian's modality forecast, speak about our hypothetical dinner guests, and much more. We hope you enjoy this episode. Hello, Sebastian. Thank you for joining me today.
Hi, Yuval. Thanks for joining me. This is your Riverside. This is your studio, I know, but we'll be guests on each other's podcasts simultaneously.
This is a crossover episode. So Sebastian, who are you and what do you do?
I am Sebastian Hassinger. I'm independent consultant and jack of all trades in quantum computing. I have been working in quantum for almost a decade now, which shocked me when I realized that when I counted up the years. First with IBM Quantum and then with AWS. And at the beginning of 2026, I went independent and started a company called the New Quantum Era, which is sort of a grab bag of all of the projects that I'm working on. How about yourself, Yuval? Tell us a bit about yourself.
I am Yuval Boger. I'm Chief Commercial Officer of Quora Computing. We make the world's best quantum computer. And I've been doing this. I only have 5 years of experience in quantum, but sometimes they feel like 2 and sometimes they feel like 20.
Same. I don't think that's going to change. I have bad news for you.
And I wasn't part of naming the company Quora, but I think it does stand for a quantum era. So, maybe you have a new book out, right? The New Quora.
That's right. Yeah, the New Quantum Era. So that was originally the name of the podcast that a friend of mine and I started 2.5 years ago, 3 years ago. And really was just, we were both very interested in just trying to get researchers to explain more about what they were doing. Kevin has a background in mathematics, but was not in the quantum industry. I was working with IBM at the time, when we first met. And so the podcast was really an excuse to get researchers on to record an interview and ask them, explain to our listeners who are not physicists, neither are we, what it is that you do in conceptual understanding. And then that kind of led into the idea of sort of accumulating more and more of this research and turning it into a narrative. Sort of the way I describe it is the book that I wish I had found when I first started working in quantum, because initially it was an extremely steep learning curve, and I would have loved to have more of a background of the history of how quantum information science came about, the history of how various modalities of qubits came about, and some of the basics of conceptually how quantum computing works and what we hope it's going to do.
What do you mean you're not a physicist? You don't have a PhD from Harvard?
No. No, neither do you. I understand. Although you do have a master's degree, so you have a graduate degree in physics, so you've got a head start on me.
I do, but at Quora, they barely let me in the door. I mean, A, you don't have a PhD, and 2, it's not from Harvard or MIT. So I guess it was my charm or my green eyes or something that made the difference.
Well, you've got a long career in executive leadership of sort of deep tech, though, right? Or like emerging technologies.
Absolutely. I was CEO for about 20 years of a couple of deep tech companies, and then served as head of business, chief marketing officer of others. I have 5 years of experience in quantum computing, a year and a half or so at Classic, which is a Tel Aviv-based software company, and then I went to the dark side, to the vacuum side, right? To Quora.
To the very cold side.
Well, to the room temperature cold side, right?
Well, but the atoms themselves get very cold.
So when I first saw your book, thank you very much for sending me a copy. When I first saw your book, and and you said an outsider's introduction. I said, well, if he's an outsider, then I'm a superconducting qubit. I mean, we just said you've got 10 years in quantum. What do you mean outsider's introduction?
Meaning coming from the outside. I mean, I had a lot of experience. My whole career has been in emerging tech, initially with, the internet in the early 90s, and then the web, and then mobile, and then open source and big data and machine learning. But when I first encountered quantum computing, it was actually at a Think conference at TJ Watson at the IBM Research Center. And all the luminaries of the time, this is 2017, they were talking about the first 53 qubit machine that IBM was going to launch the following year. And they were talking about the theory and the experimental results and the way they were building these machines. And it sounded like science fiction. It was just so completely, it was, the stereotypical mind-blowing moment, right? I mean, I only understood 25%, and I'm a pretty bright guy. I'm used to understanding most of what's going on around me. So it was just, I mean, it was very compelling, but it also felt very inaccessible. So, I started. I was helping them with the open source strategy because they just open source Qiskit. So that was relatively understandable for me and accessible. I knew open source. I knew, how to manage community efforts around those things. But I really wanted to get more deeply involved, and it took a lot of very generous physicists, answering a lot of really dumb questions for me to even start to feel like I got a grip on what was going on. So that's what I mean by outsider. I mean, this is the book, as I said, that I wish somebody had written it, and I'd found it, in December 2017 after going to the Think Summit, basically.
I sympathize with a lot of what you're saying. When I interviewed at Quera and came to visit the Boston office, and they showed me, oh, well, we've got these rubidium atoms. We hold them in place using tiny lasers. They're 4 microns apart. We shoot laser, and then we take a photograph and see how they're doing. It's like I came back home and said, this is, it's science fiction until it isn't, and then you
Yeah,
just see it in your eyes. It is
yeah,
just incredible. How
it
many
really
times?
is.
How many times in your career, and does it get more or less over time, do people tell you that a qubit is 0 and 1 at the same time?
um, I do. I sort of, in the book, there's kind of a running joke to a certain degree of like, this is the kind of explanation that will make physicists sort of turn green and that's start to have steam come out of their ears. I mean, there's that, and also the that entanglement, requires faster than light transmission of information. That's Olivia Lanes from IBM. That's her most favorite. But Yuval, the other thing was, the one that always grinds my gears is it tests all the possibilities at once, and then comes up with the right answer. But in a few years ago at the Simons Institute, I interviewed Peter Shor, and I asked him, how much does that explanation bother you? And he said, well, that's kind of what it does. So, I mean, it's, this is, I think, I'm guessing, as central to your motivation for what you've written as it is to mine, which is we this quantum stuff is so weird, and we really don't have good language and metaphor and analogy to explain it or get an intuitive kind of grasp about it. That's when I was reading Quantum Bits, your collection of comic strips and explainers of all these core concepts in quantum computing. That was the overwhelming sense I got from that too. It's like it felt like a product of your struggle to find ways to explain and make these concepts, tangible for people. Am I right?
Yeah, let me share the origin story. I mean, actually on the podcast as well. So we're both fellow podcasters. How many episodes have you done to date?
94.
That's really good. Coming almost up
Thank
to
you.
the century mark.
Yeah,
I think I
we're
did.
planning something really special for the 100th too.
Well, I should be the one, right? I think I did close to 200 now on the Superposition
Wow.
Guys podcast, and then I had 60 or 70 when I was at Classic and the Qubit Guy podcast.
Right.
But actually, I've been podcasting for probably 20 years. I
I
used
saw
to be
that.
the VR guy, the virtual reality guy, and then I was the charge guy when I was doing wireless charging,
Huh.
and it just became second nature. It's
Yeah.
actually a way for me to do two things. One is to learn. You know, I I basically ask the questions that are interesting to me, hoping that they're interesting to my
Same.
audience. It's I, there's a story about Steve Jobs that Apple had one customer, and that was Steve Jobs, and he was sort of the conduit in the entire world. If you made him happy, then he had a good sense. And the other ended up being really good business development tool because once the microphone is off, and we've also
Yeah.
already created a relationship. Hey, what do you know about Quora? Did you have $42 million lying around? I can sell your quantum computer. You know, whatever it is
Do you have
at that
Stripe?
point.
Do you take Stripe?
A payment plan, right?
Yeah.
Um, and then on the comics, I always wanted to do. I mean, I don't know what always is, but it's been a long time since I wanted to do quantum comics, and I think a couple of years ago I came up. It was sort of brainstorming with myself and my favorite AI assistant on character names, and ended up with this Atomique and Quantessa
Yeah.
that I liked. And I couldn't find any good quantum jokes. I mean, they're always about, oh, my keys are here and there at the same time.
Yeah.
They're
Yeah.
either
Yeah.
about the keys or about the cat. And it was like, okay, well, I can't do anything with that. But then at some point, I said, well, actually, maybe they could explain some physics. Maybe they could explain entanglement
Hmm.
and superposition and neutral atom and Rydberg atoms. And ultimately, you can find an explanation of what QLDPC code is
Yeah.
uh, in cat qubits and what have you.
Oh, it
Um,
gets really advanced. I mean, at first I thought, well, this would be great for kids. Just reading the first few, and it was, the very basic superposition entanglement, which are weird enough and hard enough to explain. But as you say, you get all the way into, past sort of Bell's inequality into error correction and even specific types of error correction. It was really impressive.
and then I had to start calibrating. I mean, on one hand, I had to calibrate the humor, so it's not just wordplay. I'll tell you a story about German humor in a second on that. And then when generating the explainers, I absolutely wanted to get away from the simultaneously 0 and 1 and try to see how can I explain that with no equations in
Yeah,
a way that's comprehensible to uh, intelligent non-physicists, right? You got to be
exactly.
curious, you got to be able to want to read, but you don't have to have not even a graduate degree to get there. And then on the humor, I mean, some of the comics I thought were pretty funny.
I use too.
And if you can explain, I just sent Scott Aronson a comic about P not equal NP, or uh, and if you can explain that in a comic, that I mean, he knows that much better than I do, of course. But
Yes.
um,
He's a
so I
good judge, though. He's a good judge of accuracy and also humor, for that matter. He's a pretty funny guy.
so once I was able to start generating comics, I said, you know what, maybe I can do them in other languages. And so I
Hmm.
generated a comic in German, just as a test. And I send it to my German friends, and they come back. It's like, They said the German is perfect, the comic is not funny. Okay, that's the first one. If they said the German is bad, the comic is funny, I could fix that. But how do I do the other way around? So it took a lot of work to be able to generate humor in multiple languages. And so I
Yeah,
have examples on Quantum Bits comics. I've got examples in Italian and French and German and Hebrew. And so we'll
that's
see
cool.
we'll see where that takes us.
That's cool. Yeah, I mean, back to entanglement. I liked not only did you avoid the simultaneously 0 and 1, but you used footwear to explain how entangled particles would behave, which I thought was very imaginative. Definitely.
How long did it take you to put the book together, and what was the most difficult part for you?
Yeah. I mean, so the book has its or I mean, I'd been thinking about it, but then I went to O'Reilly's sort of unconference, it's Foo Camp. It's like a retreat. O'Reilly Books has or used to have. I think they've gone to more virtual events since COVID. And I met Mike Lukitas, who was the VP of content for O'Reilly, and we were just chatting. He was asking me what I was doing, and he said I've always loved this book called The Soul of the New Machine by Tracy Kidder. It's an incredible piece of work that follows an engineering team as they built the mini computer, or they built a mini computer, which is a competitor to IBM and DEC back in the early 80s. It's really well written, and it really gets at the passion that the technology requires, and the creativity and the discipline, which I always found fascinating. So when Mike and I were talking, he said, "Oh, you should write a book and call it The Soul of the New Machine." So he just he pulled exactly the right reference out of the air to sort of inspire me. Of like, okay, that's a sign. So I started working on the proposal then, and it was hard because it's a huge topic, and every chapter could have been a book, really. Right? I mean, there's a chapter on how quantum physics sort of came together in the 1920s and challenged the ideas of classical physics. And that, obviously, there's entire books written about that by people who are far more deeply experienced and have the expertise than I do. So I think that was the most difficult thing, was sort of, how do I span all of the parts? Because I really did want to give a broad and relatively shallow introduction, so you could get a sense of the whole landscape. And that was what was the most challenging, was just researching all of the different aspects, but then holding back from going too deep into any of them. That was sort of the balancing act. What about yourself?
I think your book is sort of the traditional route. You have an editor, you have a publisher. We have a history in the family of self-publishing books. It started. My son in high school was really into investing, and he put together this investing for kids book, and
Oh,
we learn how
cool.
to self-publish, and it's there on Amazon. Actually, also has comics, but at that time he had someone draw them. And I published a children's book, a story I wrote for my kids. It's about a boy who sort of goes through his father's wardrobe and then tries on his big
Hmm.
pants and his suit and his tie, and so he learns about sort of big and small and wide and
Nice.
so on. So we had the experience. So I said, oh yeah, I could just publish it myself. I think the challenge was first calibrating the level of explanations, right? And although AI certainly played a big part in helping me put the book together and putting it in the right format, and the comics are AI generated, there's there's so much human supervision in this case, my
Hmm.
supervision. Is that correct? Is that scientifically accurate?
Right.
Do I have too many terms, or do I have not enough terms? I mean, I could make this a 500 page book, or we could make it a shorter one. I actually did make a neutral language version that we
Right.
give away at trade shows.
That's
And
great.
then also the sequence. Am I referring to a term that I didn't define
Mm.
yet?
Hmm.
That was a challenge. But overall, I think it took me. And obviously, this is not my real job. This is more of a nights and
Right. Yeah, same.
weekend project. I think it took me about 2 months to put that
Wow.
together, start to finish.
Wow. That's very fast, actually. I would have thought it was quite a bit longer. It took me almost 2 years to write, so I'm obviously slower than you. I did most of my writing on planes too. I found that was the most, because I could just block out, don't get on the Wi-Fi, ignore email, and get like 3 or 4 or 5 hours of writing done.
And the interesting thing is now that initially I started publishing comics on Quantum Bits Comics. It's a small website, and then putting them. Hey, this is Sunday Comics. I'm going to put them on LinkedIn every Sunday, and Medium and Substack and so on. And after a while, I said, I should actually make a book out of it. So it didn't start as a book; it just started as a collection of a few comics. And then I got a couple of requests to make semi-custom or offshoots versions
Mm.
of this. Not exactly the movie rights, not yet, but there is a professor of education who asked to collaborate with me on creating a version for high school kids,
Oh, that's
which would
great.
be a lot of fun. There's a quantum summer camp, and hopefully we'll get to use it there. And
Excellent.
then a European physics professor that wants to teach quantum at business schools says, "Oh,
Oh, good.
could we do this other thing?" So I've got the next couple of weekends fully planned out.
That's great. I mean, that's my hope too, is that you got tangible evidence that your work is going to lead to, more people being introduced to the topic and having an easier path into it and potentially finding, a career even in some aspect of quantum. And that's I mean, I haven't, because the book just got released on the weekend. I haven't had that kind of validation yet, but I'm certainly hoping that will be the case. That it'll be something that helps people, find their way in.
You mentioned that history rhymes with the early internet. Do you feel that quantum is progressing faster, slower? How are you thinking about that?
That's a really good question. I I think, I mean, I tend to think more in terms of the earliest days of classical computing, right? So the late 40s, early 50s, you've got von Neumann at Princeton and ENIAC at Penn, and there have been some, Colossus and Z1. There have been some previous sort of examples, but it really starts to get traction post-war, and to turn into something that resembles the industry that we recognize today, it's really like 40 years, right? It's sometime in the early 80s, basically, maybe mid 80s. So from that perspective, I think quantum is pretty much on the same track, because you've got sort of the starter's pistol at Endicott in 1981, and the sort of beginnings of machines that look like they might be able to do something really interesting in sort of the 2015 to 2020 kind of range. So from that perspective, I think we're moving along about the same pace as classical computing did. I think that there's a very strong chance we're going to see acceleration soon. I think that the fact that we have the internet and open source software and GPUs and massive amounts of compute in the cloud and storage in the cloud, all of those tools are bound to accelerate the progress overall. Once it's, I wouldn't say fully, but once it has emerged from the physics lab and starts turning into a production technology, it's more of an engineering, design and engineering kind of challenge. I think the thing that holds us back right now, holds us back. The challenge that we're still facing is that there's fundamental science that we need for all of these modalities to, get better fidelities or get better scale or get faster operations or whatever the particular challenges are. There's still real physics breakthroughs required. So yeah, I mean, I think from your perspective, I mean, you've been now 5 years in the industry. QR's actually moved pretty quickly in that period of time. Is that? I mean, that's certainly how I feel from the outside. Is that what it matches your experience on the inside?
Yeah, I think a lot of what you described is absolutely true, and in my experience as well. Sometimes I talk with customers, and we talk about ChatGPT, and ChatGPT being sort of an overnight sensation that was
Hmm.
30 years in the making, right?
Right.
Because everyone was
Yeah.
working on AI, and then there was the AI winter, and then no one cared
Many of
about
them.
it, and then all of a sudden, oh, I can actually do this thing, and now it's exploding. So the same is with quantum, absolutely. If you look at the Quera computer, there are easily, um, I think, at least 5 Nobel Prizes in physics inside it, not by Quera team, but whether lasers or tweezers
Yeah.
or other things. So it does take time to develop, but it is accelerating at really an amazing pace. And when I look at Quera, um, I sincerely believe that the future is closer than most people think.
Mm-hmm.
That
Mm-hmm.
and that sort of the million or the billion, maybe $1 trillion question is, when can you run this or that algorithm? And what we're seeing is, on the other hand, one hand, the hardware gets better. Used to be, oh, I have a 5 qubit machine or a 50, and now Quera and Harvard, maybe in reverse order, have demonstrated a 3,000 qubit
Mm.
system. And then the algorithms um, are requiring fewer resources than
Yeah.
before. When
Yeah.
Professor Shor created his algorithm, he thought it would need 1 million qubits, give or take. And now you can say, oh, actually, I can run it on 30,000 qubits or
Yeah.
something of that nature. So
Yeah.
the gap is really narrowing.
Yeah.
And the other thing I agree with what you said is that the focus is shifting. It used to be that Quera's work was probably 95% science and then 5% everything else.
Right.
And now there's so much more engineering, and how do
Yeah.
we build it in a repeatable way? How do we serve a system? What does the software look like? It's not enough to have a lab demo that works for 5 minutes on a Tuesday
Yeah.
morning.
Yeah.
And you were at Bracket. We have been really fortunate to partner with Amazon, and our initial machine, Aquila, is now 3.5 years on Amazon, running 130
Amazing.
hours a week. That's
Yeah.
quite an achievement. And I can
Yeah.
tell you, I joined Quera a month before the Aquila launched.
That's right. Yeah.
And so I go to the CEO and said, okay, reporting for duty. What do you want me to do? And he says, I'm really busy the next month. We got to launch this thing. Why don't you go to Pedro and he'll tell you what to do? And and that's how I started my career at Quera.
Well, you can't go too far wrong with Pedro's advice. He was actually one of the technical reviewers on the book, so he very graciously read through an early draft and spotted all the mistakes I was making and helped me correct them. So he's very generous with his time too.
So do you really think that neutral atoms are going to win, and then they're going to be overtaken by other modalities?
I mean, so you're referring to the coda. I felt compelled to sort of at the end. I mean, the most of the book is history and context for creating a basis for understanding. But I felt like everybody I was telling about the book or read was like read early drafts, wanted me to tell them so what's going to happen basically. So I had to add a section at the end. It's my best guess based on where the strengths and weaknesses are today. So when I look at neutral atoms, it is clear to me that there's an advantage that is accumulating for neutral atoms right now around scale and implementation of error correction. Right, the incredible experiment that Vlad Vuletic and Misha and the rest of their collaborators published for 48 demonstrating 48 logical qubits. I mean, that was not just logical qubits, but a lot of them. Right, really impressive. And it was just it wasn't a full life cycle of error correction, but this is now 2 years ago. So 2.5 years ago. So there's been progress since then. So I think there's a lot of strengths in the platform, but at least at the moment, the biggest weakness is wall clock speed, right? Like the speed of operations. It takes a lot of time to prepare and move the atoms in place and then move them around, shuttle them around with the lasers. That's a time-consuming set of operations. Now, can that be accelerated? Maybe. I don't know because I'm not inside your R&D labs looking at your secret stuff. If it can, and it can be competitive with, superconducting qubits are 1,000 times or more faster in terms of their operations. If you can get competitive with that, then maybe that advantage has even more legs. But that's my read at the moment. And then ultimately, the story that gets us to millions or billions of qubits feels like it has to ultimately rely on either CMOS techniques of fabrication at scale, or photonics because of the sort of the scale of photons themselves. You can get a ton of photons, and the fact that they're less sensitive to heat and other environmental factors. So that was kind of the way I staged it, sort of neutral atoms or atom-based qubits, short-term advantage, superconducting midterm advantage, and then spin and photons in the long term. But I'm sure you see that differently.
Well, yeah, let me put on my Quora hat just for a second.
Yes, please.
I mean, if you think neutral atoms are slow, you should look at trapped ions. Now that's really slow. But a couple of things. First, I mean, you mentioned Professor Vladan Vuletic, who was one of the co-founders of Quora and our CTO today. We had a partner meeting a year and a half ago. We call it the Quora Quantum Alliance. We have these partners that work with us and go to market that believe in neutral atoms. And Vladan was giving a guest lecture, and I asked him, "Hey, Vladan, this sounds great what you're telling about Quora and about neutral atoms. Do you think this is really the winning modality?" And at that time, he said, "For the next 5 years, I am very confident that neutral atoms is the winning modality. And later, beyond that, I don't know." So this was a year and a half ago. 6 months ago, I asked him that question again because we have the annual meeting. So,
Right.
okay, well, Vladan, last time you told me this, what do you think? And he says, now, based on the recent developments, I feel comfortable about a 10-year time scale. And
Excellent.
of course, to your question, so first, obviously what matters is time to solution and not clock speed, right?
Yes.
Yeah. And one of the things you see with neutral atoms, you see parallelism, you see super efficient quantum error correction. I mean, there was a paper from the Harvard team not too long ago that showed that for quantum memory, not yet computation, the ratio between physical qubits and logical qubits is not 1,000 to 1, it's 2 to 1.
Wow.
And
Yeah,
so you don't
I read
need
that.
a million qubits, right?
Yeah.
You don't need a million qubits.
Right.
You
Right.
just need to use the right technology and right error correction code. So you get into
Is
that.
that still, I forgot, Yuval, is that still LDPC codes?
Yes.
Or,
Yes.
yeah, okay.
Now I simplified a little bit. It's not 2 to 1. It's like 2,000 to 1,000. So it's a little bit more complex
Okay.
than that. So these sort of overcome or compensate. There was also algorithmic fault tolerance that showed that you don't need to make the syndrome measurements every operation, but every algorithmic blocks.
Right.
So there are all these
right.
ways that essentially compress the time to solution
Yeah.
by orders of magnitude.
Yeah.
And then there are the inherent advantages of neutral atoms. All the atoms are identical, room
Yeah.
temperature operation, easy to scale, bill of material that's reasonable and doesn't feel like a B-2 bomber in terms of the cost or
Yeah.
size. Right.
Yeah. Or an entire data center for just one machine.
Yeah. Did you see these LinkedIn posts that someone is converting Central Park into a big data center? That'll go really well, right?
Yeah, that'll.
So tell me sort of some just between us, right? The inside story. So how far is the book from your first draft? What did the editor say when he saw the first draft?
I'm a weird writer in that I procrastinate and I'm slow, and then what I produce is pretty close to a final draft. I do a lot of painful interior work when I'm writing, and that goes all the way back to high school. I've always been like that. I don't know why exactly. So what I did was I think I wrote 2 or 3 full proposals and then scrapped them. And because that was what I was describing at the beginning or earlier on about the trying to come up with the right structure that had enough breadth and not so much depth that it got bogged down. So I kind of, I felt like I was going down rabbit holes in the first 2 or 3 proposals, and then eventually hit on the structure that's almost exactly what it is now. And then pretty methodically kicked out sort of first drafts that only needed light revision, no giant rewrites, no big structural changes. So, I mean, like I said, for whatever reason, I front load the effort, and I do a lot of sort of hand wringing, and I would tear up my hair if I had any left. Maybe that's where it all went. I don't know. And then produce something that's pretty close to final when I do actually manage to get the words on the screen. How about yourself? Do you have a very like an iterative process? You do a lot. You talked about sort of trying to refine, especially the combination of the explanation and the humor. That seems like a very delicate balance.
Um, I like to ship stuff.
Mm,
When I was running a virtual reality company, one of the models was there's a lab, I think, in Canada. If I hope I still remember the name correctly. It's a Professor Stephen Feiner, and he had a rule for his postdocs. Every week, you're going to complete an experiment and do
mm.
something, or else you're gone. So,
Wow.
what have we shipped this week? What have we shipped this week?
Wow.
So I work fast. I do work pretty intensely. Um, I do rely on intuition. So, I mean, even at Quera, I remember seeing on the internet these AI generated Lego models of quantum computers. I said, you know what?
Yeah.
Why don't we just actually make one? And
Yeah.
so we made it. And then
That was cool.
what else could we do that's cool on Swag? Oh, we use optical tweezers. Let's make physical tweezers and do that. So I think, yes, Quera is going to win the quantum race, but I definitely think we are winning the Swag race. No one has
More
anything
importantly.
even close, right, to that. I did have a good number of iterations on the physical aspect. I
Mm,
didn't want it to feel like a textbook. I didn't want to feel like a newspaper. But then you have comics and text, and I didn't want it to be a 1,000-page missive. And to how do you? So I experimented with different book sizes, and printed it out, read it. Oh my God, this is so bad, and this is cringe, and this is not. And then of course with a closed network of family. My family probably are my worst critics. Maybe they know me the best. My son, for instance, anytime I said, well, yes, I used AI here and here and here, and this is a really human review. He says, no, 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 that doesn't work. If it's not worth time writing on your own, then it's not worth time reading. Oh, okay. Uh,
yeah.
so if it passes
There's a
my
lot of
family,
truth in
then
that.
yeah, if
There's a
it
lot of
passes
truth in
my
that. I
family,
feel like we're heading towards a future where, AI will generate the majority of the text that we send back and forth and will ingest and summarize the majority of the text that we send back and forth. And maybe it'll just leave us to write the stuff that we really care about instead of, empty fluff. But we can
it
hope.
used to
I
be have
used,
your
sorry, go ahead.
it used to be have your lawyer talk to my lawyer, and now have your AI talk to my AI, right?
Totally. Totally. Absolutely. Yeah. And I was just going to say, I used AI to a certain degree, but mostly as a research tool. Because I started writing it 4 years ago. So it was very early on. And what I would refer to as is like having a conversation with Wikipedia, basically, because it was and the archive for that matter. I would ask it for examples of X or what's a good paper for explaining Y or whatever, and it would do a sort of shortcutting Google search essentially, and then having summarized results with sources that then I could trace back, because that was the thing from the very early on stage. I knew that the language that would generate would be the kind of stuff that nobody wants to read, really, because you can tell it's a machine, even the best of it. You can still tell it's a machine. And B, the biggest risk is hallucination, right? I mean, coming up with some physicist who doesn't exist or a theory that doesn't exist or whatever would have been embarrassing. So I definitely wanted to avoid that.
Let me ask you a question that I ask my team, the commercial team. When they produce a document or an event or something, I always ask them about the outcome. What do you want the customer to do when they read that, or how do you want the customer to
Yeah.
feel? That's
Yeah.
probably the best question.
Yeah.
So, what's your answer? So, what do you want people to walk away after reading your book?
Yeah. It's a really good question. Because, you know, I referenced sort of the feeling I had at Think Summit 2017, it was exhilarating, right? I mean, as bizarre as this stuff is, as hard as it is to wrap your head around it, it's also so exciting that we're, not only, building a better understanding of how the universe works and what is reality and what's the operating system of the universe, but we're harnessing it to calculate things for us. It's like when you really dig into the deeper sort of profundity of what we're doing. We're engineering the raw material of the universe or raw energy of the universe into these instantiations that are like the Oracle of Delphi, right? It's asking the universe for answers and it tells us. Like that's just it. I can't think of anything more exciting, but I understand how intimidating and confusing and bewildering it can be from the outside. So feeling like that sense of that scale of wonder and excitement is accessible even if you're not a physicist, even if you're not in one of these labs or able to do the extremely complex math in your head on or on a whiteboard. It's still something you can access and experience, even at this early stage, before it really gets solved and distilled and packaged and sort of productized for us. It's still in this raw exploratory stage that anybody can actually get involved in and participate in.
For me, so obviously I wanted it to be accessible. Quora deals with sophisticated high-end clients, and we don't usually target the more the entry level. So this book, which is a personal project, I wanted to go a little bit more on the masses. I think the takeaway is that quantum is magical, but it's not magic.
Yeah,
And
that's a good way to put it.
and I hope one of the things that I did in the book is in the back of the book there's actually a glossary. So if you say to yourself, what is a quantum radar, or what is a quantum phase estimation, then you actually say, okay, here's the page. Let me read, half the page of an explainer and see this comic, and maybe I'll get just a little bit better sense of what's going on. So what's the sequel, Sebastian?
um, well, the original idea was something along the lines of the soul of the new machine. And so we're in this stage where sometime in the next 5 years, I feel there's a very high probability that somebody ships a quantum computer that's simply not simulatable by classical means, because it's on the order of 50 logical qubits that can all be entangled with one another, and 2 to the 50 is too many states to be able to directly represent. So there is going to be some moment where a machine exists that is the beginning in reality of a new era of quantum information technology. And that's what I want to actually sort of, you know, journalistically explore the team and the effort and the competition and the marketplace and the landscape and the public sector efforts and the private sector efforts and the global efforts, that are the landscape right now, and are going to produce that moment when this machine exists, maybe a Quera machine.
5 years?
Yeah.
I think you're pessimistic.
Good.
I do think the future is much closer than you think. I
That's
believe.
great. That's great. I mean, I'm going off of public roadmaps, so I know that there's private forecasts as well that could be more aggressive. So, but we should plan to get together when the sequel to each of our books is out. You've got your customization and your sort of broadening out for other educational audiences, and I've got my part 2, which working title is One Perfect Qubit, by the way.
One perfect qubit. Yeah, I think building habits is a good thing. So podcasting, for instance, has been a habit of mine. So if I haven't done anything in 2 weeks, I'm like, something's wrong.
Yeah.
and so actually publishing a comic every week is building a habit. I don't know about books yet. Sebastian, when I usually when I end my podcast, I ask people a hypothetical. If you could have dinner with one of the quantum greats, dead or alive, who would that be?
That's a great question. I mean, the first impulse is Feynman, just because I've read his books. He seems like a very original thinker and somebody who is, brilliant, and also brilliant at explaining. And so I think I would go with Feynman. How about yourself?
So, Feynman, I published statistics, a histogram of answers, and Feynman, of course, is the
Yeah,
lead. The
I
other
know.
Feynman story is that I was chatting with Professor John Preskill, and I asked
Mhm.
him that question, and he said, and I told him everyone says Feynman, and Professor Preskill was a student of Feynman, so he's like, "Oh
Yeah.
no, I had plenty of dinners with Feynman," and and then he said, "Oh, actually, I would love to have even one more because to see
Oh, that's nice.
how he thinks about that, but not
Yeah.
to avoid the question." Um, for me, I think it probably Einstein, and it took many episodes until I heard someone say Einstein. I think that when I was really young and even stupider, I thought I was playing the violin and I was studying physics, and I said, I liked physics in very much in high school. I said, maybe I can be the best violinist out of the physicist and the best physicist out of the violinist. And then Einstein, he was he was a very good violin player, and of course
Yeah.
his physics degrees
Pretty
are
good at physics.
pretty good at physics too. So that kind of completely ruined my plan. I had to go
Yeah.
to
You could have switched to like French horn or something.
when I speak with quantum CEOs and they tell me about their modality and how great it is, sometimes you ask them, well, okay, if this is so great, why is not everyone doing it? And I think, I think it was the CEO of The Rock that told me, I spent 20 years getting to this point, and I have forgotten things that most people haven't even learned yet. And you speak about the French horn, so I still play the violin and I know the notes. But if you ask me to switch to a French horn, that's not gonna work. Yeah, it is
Yeah.
completely different way, completely different modality.
Right.
So
Right.
switching modalities for me is not gonna work in this
Yeah.
case. Well,
I
Sebastian, thank you so much for spending time with me today.
absolutely. Thanks to you, Yuval. I'm looking forward to hearing the episode of your podcast that I'm appearing on, and then you can hear the episode of my podcast that you're appearing
And
on.
where do I get your book?
So newquantumera.com, the podcast, the newsletter, the book, and Amazon and anywhere else that you buy your books. How about yours? Say the name of the website
So you
again.
can certainly buy it on Amazon, Quantum Bits, a comic book guide to quantum computing under my name. You can also go to quantumbitscomics.com/buy and see both some of the custom editions as well as a link to buying that book.
Excellent. Thank you, Yuval. Talk
Thanks
to you
again.
again soon.
Bye-bye.